Section 13.3 and 13.4, what you're going to see is a lot more of the notes actually written into the pieces of paper you've already printed off. So if you've printed notes, you're not going to have nearly as much to write today. If you have not printed notes and you're trying to scramble to write things down, this would probably be a pretty good day to either go back and print them later or to take some pictures as we work our way through so that you don't have to spend so much time writing it, because I am going to move more quickly since I've typed them in. All right, so to start with, the title of the section is called Truth in Lending, and it refers to the Truth in Lending Act. This act was passed in 1968 and addressed two major issues. One, how can we tell the true annual interest rate that a lender is charging? So typically that might be something we want to know if we're comparing different kinds of loan opportunities. And then second, or investment opportunities. And then secondly, how much of the finance charge are we entitled to save if we decide to pay off a loan sooner than originally scheduled? So if we pay something off faster, how much do we save by paying something off? Okay, it's always a good thing to save money, right? Sure. So how much are we entitled to save? Well, we're going to be taking a look at this table number 5, right? This one right here is going to actually be able to address for us, it will support us in answering those two questions is what it will do. All right, so we're going to take a look at Ann and Andy, and we will work with this table as we go, and I'll show you how we use it. So remember Ann and Andy from 13.2, they're the ones who bought the refrigerator. So shortly after the refrigerator dies, the dishwasher died. They again decide to finance a new dishwasher. It cost $500 with $100 down. But this loan was only 6% add-on interest for 18 months, and we're going to find the APR of the loan. Okay, so there's no, like interest-free time frame. None of that stuff existed from last time. This is just flat out interest from the beginning, 6 months. I'm sorry, not 6 months, 6% add-on interest for the loan. All right, so the first step is that we're going to find the amount financed. If you remember, the amount financed is the amount of the purchase of price of an object, in this case, the dishwasher, and then we take off how much they pay for it from the get-go, which is what we call our down payment. So what was the purchase price of the dishwasher? Yep, $500, right? And what is their down payment? It's $100. So how much money are they going to actually finance? $400. Everybody good so far? We're going to do that same process one more time today where we look at down payments. It's going to set up a little bit differently, but that's the way we look at it. All right, so we're going to find the finance charge. That's the same as saying the interest on the loan. And interest, as we've been working with, is I equal PRT. Nod your head if that looks familiar. We've done that several times. Okay, good deal. So P is the principal. It's how much we borrow. How much is that in this scenario? $400. R is our interest rate as a decimal. What is our interest rate? Yes, so 6% and it's 0.06 as a decimal. And T is the time in years. So how long are we going to borrow this, or Ann and Andy going to borrow this money for? Yeah, 18 months. So how would we represent that in years? 1.5. Okay, grab your calculator. I'd like for you to multiply 400 times 0.06 times 1.5. They're out. I'm out. Oh, is there one more? There's one more. I didn't see it from my angle. Okay, good. Okay, does anybody have a value yet? 36. Okay, so they're going to pay $36 for the luxury of borrowing the money. Everybody good so far? Okay, cool. Step 3. So I'm doing the steps in sort of a modeling process. Some of the questions in my math lab will show this sort of step by step like this, where they'll guide you through it too. But some of the problems will simply just ask the question, and you're going to do all these same steps, whether it guides you through them or not. But now you've got a model to follow, hopefully, as you ask those questions or are asked those questions. All right, so step 3 is to find the finance charge per $100. So here's the way that this works. This is called H. And the way it's found is that you take the finance charge and you divide it by the amount financed and you multiply that by $100. All right, so what is our finance charge? $36. What is our amount financed in this problem? $400. Yep. And we're multiplying that by 100 when we're done. So we're going to take 36 divided by 400 and multiply by 100, and this is going to give us a value for H. It's a nice value. This particular one works out beautifully. What'd you get? 9. Okay, now you don't really know what you got. I mean, like you found 9. Great. What does that tell me? Well, this is where we get to use our table. Okay, so does everybody have 9 written down at this point? Okay. So this is my table that was in the book itself, so it's a little bit harder to read than the one in front of you. But as you're taking a look at it, you can still follow with the paper that's in front of you. So what we're going to do is we're going to use table 5. We're going to locate the nearest H value in the correct row. The column header will tell us the APR for the loan. Okay, so here's how this works. On the left-hand side are a bunch of months. We're going to find the month that matches our loan. How many months is our loan? 18. So we're going to go to the column, or the row, that has an 18 in it. Everybody good so far? And we're going to go along this row until we find a value inside the table on the row that says 18, that's as close as possible to 9. It could be smaller and it could be bigger, but you just want the one that's as close as possible to 9 on this row. So in some sense, I'll highlight the whole row green so that we can keep track of it. This is the row we're on. These are the only numbers I'm looking at. And I want to find the number 9, or as close as I can get to 9 in this row. What'd you find?
Is it as close to 9 without going over?
It could go over, but it is the closest one to 9. Ours on this one is actually not going to go over. Yeah, the 8.93 is closer than the 9.35. Because this is as close as we can get to 9. Everybody good so far? That's how we're using H. So all these values inside the table are H's. And then we go straight up to the column header here. And this right here is the APR. So the APR for our problem is 11%. Now, notice there's a little bit of lack of accuracy here to some degree. We found the closest to value of H, but it wasn't exactly 9, right? It was really close to 9. So is it really going to be 11%? Well, no, it'll be slightly different than 11% because we had to round to get the right number. But it's close enough to live with, okay? You might also notice some other sort of inherent flaws. I mean, what if the months were 16 months? I'll have a row for 16 months, right? Well, none of the problems you have are going to have that problem, but in a real life scenario, we would have a much more extensive table that we would be using, right? And it would have like every single month written out. And can you imagine how big that table would look? It'd be crazy, right? So yeah, and there's also calculators that'll do this aside from a table. Yes?
Just a question of curiosity. You don't have to answer it if it takes too long, but how do they calculate the numbers in the center? Do they like have a formula that takes the months?
Yeah.
And that? Okay.
Yeah, there's a calculation that they're making for those values in the middle, correct? Yeah. Okay. Everybody good so far? Now, what I want you to notice is that this 11% does not look like 6%. 6% was an add-on interest rate, right? But it's 11% that's actually the APR in this problem. That's what we'd be using to compare. We'd be using this 11% to compare it to some other loan with other conditions and so forth to decide what kind of an interest rate we're really getting with this kind of a loan. All right, let's take a look at what happens next. Because the whole point of this is really to try and figure out if we paid off the loan early. Well, we did part of it. This was part 1, right? The Truth in Lending Act addressed 2 issues. We've talked about number 1. What's the real APR that's going on? Part 2 was to figure out, what do I do when I pay off a loan early? How much am I entitled to save? So there's 2 ways to find unearned interest. And they're not like, I could do either one of them and I'm going to get the same value. You will get different values if you choose these 2 different methods. So pay attention to the wording of the question. If it tells you to use the actuarial method, that's the method you have to use. If you use the other method, you're not going to get the right answer, and vice versa. Okay? So actuarial method looks like this. So if we're an installment loan, that's the kind of loans we're talking about, not credit cards, right? When they bought the refrigerator, when they bought the dishwasher, when you buy your car. It's requiring monthly payments, which is paid off earlier than originally scheduled. We're going to let capital R be the amount of the monthly payment. K be the remaining number of scheduled payments after the current payment. We'll talk about that with a scenario so you can see what that's referring to precisely. H, that's the same H we saw before, but there's a little bit of a twist to what we're doing when we're paying it off early that you'll see. It's the finance charge per $100. Thus, the unearned interest rate is calculated with the actuarial method as follows. U is K, the number of monthly payments that I don't make, times R, the monthly payment amount, times H over 100 plus H. It's a ratio. Okay, so at the very least, jot down that formula. I'll write it on the next slide as well. Not only do we want to know what the unearned interest is, that is, how much money do I save? Typically, at the point in the loan where you do this, you want to know what is the payoff amount? What money do I need to pay today to be done with this loan forever? So, payoff amount has a formula we'd like as well. So, all the conditions above are the same conditions. It's an installment loan. Required monthly payments are paid off early, along with the current payment. Has K additional payments scheduled after the current payment. The unearned interest U is U, and then we are disregarding any possible prepayment penalty. I'll talk about that in just a second. Then we calculate the payment method payoff amount as follows. We take K plus 1 times R and minus the unearned interest. Now, if we put some context with this, parts of this at least will seem quite reasonable, and you'll be like, oh, I get why they're using that number there. Other parts of it are probably going to still be a little bit hazy. You guys aren't actuaries, that's okay. But there's portions of this that are very reasonable, and they make perfect sense. But within context will be easier to explain. So you ready to look at Ann and Andy? Okay, so for Ann and Andy, Ann got a new job and it came with a signing bonus. Have you guys ever heard of a signing bonus? Do you know of any jobs that have them or have had them that you've seen before? Yes?
Whenever you're applying to the military, sometimes hey, if you join in this career specifically, we'll give you this much money.
Wonderful. So military in certain specific careers will give you a sign-on bonus. Any others you've seen before? Yeah, that's the one that I know of too. Nursing especially happened after COVID, right? There was a lot of people who got out of the medical profession, and there was a huge shortage of nurses, and there were sign-on bonuses for nurses at certain locations, and in general. Teaching does as well sometimes. So there are some districts, there are some locations nationwide and so forth who will offer you more money to go there and a sign-on bonus. Most sign-on bonuses have some caveats where you have to work there certainly the time before you get the sign-on bonuses. But these are professional careers, and some of the careers that will do it too that are not, like service industries. So like being a waiter or waitress, right? Server will sometimes come with those depending on the location and so forth. So sign-on bonuses are a real thing. So Anne, she gets one that's very exciting for her. And so in an effort to get her finances under control, the couple decides to pay off the dishwasher early. They had originally agreed to 18 months and have paid 5 months so far. We're going to find the unearned interest using the actuarial method. So let me just write down the formula for unearned interest back at the top since we have it not on this screen at the moment. So it says U equals K times R times H over 100 plus H. This is unearned interest. All right, so just going in order, we're going to identify what the K, the R, and then we're going to find the H value, which is a little bit less direct than you might be imagining. It's not 9. Let me just say that right now. It's not 9. So K is supposed to be the number of payments that we won't be making, right? So we've already paid how many months? How many months have Andy and Andy already paid this loan on? They've paid 5. They're currently paying 1, right? And how many will they no longer pay in the future? There's 12 left after that. Does that make sense to everyone? K is 12. It's the number of payments that they won't have to make. Okay, so R is the regular monthly payment. Well, the regular monthly payment needs to be the total amount they owe divided by the months that they're paying it out for. So how much did they borrow? Flip back if you need to remember. Yes, Macy, it's $400 they borrowed. How much interest are they going to have to pay for that? We did that too. How much was it? Okay, that's a percentage. There was a dollar amount that I'm looking for. It was 36. $36 of interest. And how many months are they paying this loan over currently? No, that's what they're trying to get it done with. But what did they sign up for? They signed up for an 18-month loan. Okay, so you're going to take in your calculator and you're going to divide 436 by 18. And this will be their monthly payment amount that they are currently operating under. What did you get? It's a little bit off. Take a look at your numbers just to check. It's 24 something. 22. Yeah, 24.22 is what I have. Okay, you ready to see how H works? I'm going to write down a little bit of details so that you hopefully write them down as well. So H is our new H. This is our new amount, or our new H. It's found by taking the K equal to 12, because we've got a 12 months we're not paying for. So we do K equal 12 in our table on the 11%, or in, I should say, maybe in the 11% column. Okay, so when we previously paid it over 18 months, H was 9. We did that before, correct? But what we're trying to figure out is what H would be for the months that we don't actually do this for now. Okay, so I'm going to flip back to my slide with my picture on it that matches your pages I handed out. So we stay on the column that's the 11% column where my original H of 9 was, okay? But now instead of looking on the row that I've highlighted in green for 18, I want to look row 1 above it because my K value that I'm working with is 12. So if I go up 1 spot instead, let's change colors, I would be here. Okay? So I'm still in the 11% row. It is 11% APR loan. That does not change. But what has changed is my number of months. And I'm not using the number of months I've paid for because I'm trying to find out how much I'm saving. So I'm saving 12 months of time. So my K equals 12 is the row I'm going to be on. Okay, is everybody okay? So what's my H value? 6.06, right? So over here where we were calculating these, my H value is 6.06. Okay, so using these pieces of information now, we can find our unearned interest. Our unearned interest is calculated with the formula above as K, which is 12, times R, which is 24.22, times H, which is 6.06, over 100 plus 6.06. And what I would suggest that you do first is to do the addition of that denominator before you go sticking things in a calculator. So this is 6.06 divided by 106.06. And your calculator should be able to handle it entering just like that, sort of from left to right, and give you a value of the money you're saving, or Ann and Andy are saving by paying off the loan early. How much do they save? Notice it can't be more than $36. Why not? It is. So in terms of reasonability, this answer must be less than $36 because $36 was the interest that they owed to start with, and they're not going to have to pay all of it. So 16.61, which is our correct answer, is a reasonable answer as well. Okay? So then, this is our money that we've saved. Our next question then is, what's the payoff amount then? Well, payoff looked like this. I'll write down that formula here as well. So the payoff is K plus 1 times R minus U. Okay, so why is it K plus 1? Well, this is the amount of payments that are left to make. So we're currently making 1. There's 12 more we're not going to have to make. There are 13 payments that remain. And the normal amount that I would have paid for those 13 payments was $24.22 each. Right? Like if I paid the whole thing out, this is what I would currently be paying for the next 13 payments. But I'm going to subtract off the $16.61 because I'm saving that in interest because I've paid it off early. So again, your calculator should tolerate this just fine. Working from left to right, multiplying first, subtracting second. How much money is our payoff? Did you get a number, Jocelyn? Oh, okay. Cannon?
298.25
You got it. $298.25. Perfect. Okay. So the last payment is she writes a check, she calls and makes a debit payment. However she does, she moves money from one account to another account, and this is the amount of money she pays off in that sixth payment that she's making instead of having to make them paid out over time. Okay, does that make sense? Okay, the actuarial method is the more complicated of the unearned interest methods, okay, because you got this table to contend with. The other method is easier to work with. It's called the Rule of 78. And it works like this. For a closed-end loan requiring monthly payments, that's the same kind we've been working with. It's paid off earlier than originally scheduled. We're going to let these descriptions work for us. F is the original finance charge. We know what ours was. It was 36, right? N is the number of payments we originally scheduled. We know what that is. Ours is 18, right? K is the remaining number of scheduled payments after the current payment. It's the number of payments we're not going to make. And we know what that one is here too. It's 12. So the unearned interest then is calculated as K times K plus 1 over N times N plus 1 times F. Okay, so I'll write this formula on the next slide as well so that we have it to reference, but we know all of these numbers. I don't have to go searching for them. They're all given to me in the previous work that we've been doing. So let me write this here at the top. It's K times K plus 1 over N times N plus 1 times F. Alrighty then. So, K. Well, K is the number of payments we don't make, which is what? How many payments are we avoiding making by paying it off early? 12. N is the number of payments we originally signed up for. That was 18, yes. And F is the finance charge that we calculated earlier, which was, it was 36. 36. Okay, is everybody okay with those pieces? And we're going to put them into this formula. So our U is 12. 12 plus 1 would be 13. Over N, which is 18. 18 plus 1, which would be 19. And then we multiply by the finance charge, 36. Now, I had a student in my other class put this in and get an answer that didn't make quite sense. So I want you to put it in. Let's see what answers we get and then decide if the answer you're getting makes sense. What'd you get? 1642 is correct. Did any of you get something that's not 1642? Okay, so if you're getting an answer and you just don't want to speak up right now, that's not 1642. Your calculator may be having some difficulty with the fact that there's multiplication, and then there's division between the two, and then multiplication at the end. So one of the ways to simplify that so that your calculator doesn't mess up is to actually find each of those values. For example, if you multiplied 12 by 13, what do you get? Somebody do that for me, or maybe you know it. 156. And what's 18 times 19? 342. And so instead of putting it in the calculator the way we originally had it, you perhaps would do 156 divided by 342 and then multiply that by 36, and that will eliminate some of that messiness that your calculator might be confusing, if it is, on parentheses, okay? But you should be getting an answer that's really close to what we had before, 1661, but it's not just off by a decimal, right? It's a very, I don't want to say it's a very different number, but it's not just a tiny bit off. It is off. It is calculated differently, and the numbers will not be super like, 2 pennies off kind of thing. That's not what we're looking at here. We will get something that is close but different. And then if you're finding the payoff amount, you find it the same way. That calculation is always the same. So the payoff amount is always K plus 1 times R minus the unearned interest. So K is 12, so this is 13, times our regular payments, which is $24.22. But our unearned interest now is $16.42 instead of $16.61. Or $16.16, what was it? $16.61, I said it right the first time. All right, again, the payoff amount is going to be pretty close, but it's going to be different. What is the payoff amount if we use the rule of 78? Do you have it? 298, and what was your percents? 44, yes. So 298.44 instead of 298.25, right? They're really close, but they're not the same.